So I'm Matt Ranney. I founded a company called Voxer. We do this voice messaging thing. We all know it on the back end. A lot of people may know me from doing Node Redis. A lot of people using Node Redis. Yay, Redis. A ton of people have talked to me in the last few days at JSConf here at NodeConf about Node Redis, and it really reminds me like how many contributions I got to help make that work, and like ton of people are using it in production, and like we fixed like a ton of bugs. It wasn't just me who made that thing. Like a whole lot of you helped contribute. So I just want to say thanks for everybody who like tried that out and like pointed out bugs and like gave it a shot, because like I think now we have a pretty good Redis library, and it's like such a good fit with Node. Anyway, just wanted to put that out there. Thanks for the community and support on the Redis thing. Anyway, so I was supposed to talk about node performance, because I've done some work with the V8 profiler and stuff like that, and found some interesting things. But in the last few weeks, I ran into some, I think, even more interesting things. As Voxer started to get more popular, we started adding more capacity to our system. We're running all Node on the back end, and it's raised a bunch of kind of interesting issues that I wanted to talk about. So before I do that, like, just backing up a little bit, like, we've always said, like, there've been some things we've been saying about Node since, like, forever ago. And I think Node's been kind of living up to its initial promise. Like, it works, it has very good performance on, like, a single CPU core. It works really well that way. It's very inexpensive to hold open a lot of network connections, and you get to write your programs in JavaScript. So it's like, those are like the key sort of like tenets of like why Node is good, in my opinion. And I think we've done a pretty good job at that. Like, it really does deliver on all those three things. But there's always this sort of nagging questions. The people who are new to Node are like, well, geez, what about all my other CPUs? I mean, isn't all like modern software multi-threaded? Like, I have Java, and like that does lots of threads. And surely in this era of multi-core computing, like, you have a good way of using more than one CPU core. I mean, obviously. And we probably did ourselves a disservice. A lot of times in descriptions of Node, we would say, oh, it's more scalable. Like, we would throw this scalable word out. And that was probably a mistake. It's at best misleading, and at worst totally wrong. Node doesn't do anything about scalability. All it does is those three things. It's very good performance on a single CPU core. It's easy to hold open a lot of connections, and you get to write all your programs in JavaScript. So that's cool, because event loops are good. They maximize the efficiency of your resources. And what we've always been saying is, okay, listen, if you run out of one CPU, like you got this amazing benefit of being very efficient on that CPU, you're out. You just get more node processes, and they can be on the same computer, they can be on a different computer, but because we have this amazing networking stack, it's really cheap to talk to other node processes. So like, don't worry about it. Like, just get more node processes, and stop computing prime numbers in JavaScript. And so, by the way, like, we've got Unix sockets, and we'll do this send FT thing, so you can move file descriptors around. And so, fine. Like, on one computer, like, we'll make it a little bit easier for you to sort of get a whole bunch of node processes. But still, like, get more node processes. That's the way to go. Unfortunately, even debugging a single node process is very hard. There are some tools for this. There is Node Inspector, which is super awesome. And if you've never used Node Inspector, like, write that down, go check it out. It is awesome. It's the WebKit, the dev tools. You can plug it into Node. It's super cool. But even with a great tool like Node Inspector, like, debugging an actual server, especially like while it's running, sort of impractical. Like, you can't really sort of step from async callback to other async callback like you'd like to. And frankly, if you have to stop it, your server stops working, and it might not actually be doing the same things if you've stopped it. Other people are talking to it, you're making outgoing connections, those may time out, or different states may be arrived at, and pausing a process is not always viable debugging Node. So, man, that's really hard. There's also a sort of a command line-y version of the same thing in Node, if you like to do it that way, but still the same fundamental problem. Like, if you stop it, then your server stops working, and that may actually not reproduce the state that you're trying to debug. So you can do what most people do, which is what I do, which is you just log a lot. You write all kinds of log statements on all sorts of things. But remember, you get all these amazing benefits. It's very efficient on one core, and you get to write it in JavaScript, and lots of connections and all that. So like, don't give up hope. Like, there's a reason that we're all here. Like, it's cool, but it's just, debugging is kind of hard. It may be ugly, but I mean, you know, you can sort of do it, do something with that. So anyway, like, here's what you usually start out with. Like, you start out and you're building your Node app, and you've got like one node process, and you know it's probably talking to some kind of database, and you're in this world I just talked about a minute ago where you're like, okay, sometimes it's complicated, but like we can figure it out. We'll add a bunch of logging, and you know we'll solve our bugs that way. But then like you get some more, you know, you get cluster, or you get whatever, you know, some way of getting a bunch more nodes on the same machine, and then like, okay, it's getting a little harder, but maybe you get more clever logging and you figure out some way to filter it down or whatever, and that's pretty cool. But then like, man, somewhere right around here where you're like, I guess we need more computers, and now you got 2 different kinds of places where you're keeping your data. You maybe have like a Redis or a Memcache if you're someone other than me. And then like, you know, probably want a real database in there too. And like, geez, like everything's talking to everything, and like there are multiple different states that things can get into because you have all these moving parts. And man, it's starting to get really complicated now. But then like, you're successful, so like you're getting a lot of traffic, and you're starting to have to separate your components. And you know, a pool of identical node processes running on 3 machines behind a single load balancer starts to not cut it. And like, holy crap, now you've got like 2 steps through 2 different, you know, a step through 2 different load balancers in different parts of your application and running in different clusters all over the place. All of these things are like, have this state that accumulates as new traffic comes into it. And wow, like if you thought debugging like a single node process was hard, like try getting like something like this, and it is a challenge. So, as you might imagine. So the thing is, like, you may be thinking to yourself, well, look, I'm a responsible adult. I have written a ton of tests, and I test all my code, and I've got a dev environment, you know, and I got that all set up, and you know, and I got a staging environment, and I do my homework, you know, like I read all the best practices, and I practice various kinds of something driven development, behavior, and what have you. And so your development is, I mean, you're on it. But the thing is, like, you can never exactly account for all the differences. Like, sure, you may build a dev environment, but like, are you really going to have as many nodes in your dev environment as you have in production? Like, are you really going to commit that kind of hardware budget to just so you can have the exact same setup in dev? I mean, probably not. You're probably going to have like 1 or 2 computers, and you're going to run a smaller version of your whole setup there. And yeah, you may like simulate some load, but like you're never going to be able to simulate like real, actual, live customer traffic. Like you'll blast some kind of synthetic pattern of something that seems reasonable, and it's probably the best you can do, but like it's not what happens when you go into production. There's just no way to recreate all of the conditions that a complicated system like this can get into, but in a laboratory environment. I mean, I don't know, I guess I shouldn't say no way, but it's impractical from a cost standpoint. Like, you're just not going to do it. You're going to try it out, you're going to write your test, you're going to do a simple load test, and you're going to be like, okay, good. Seems like it works when I try it works when other people try it, throw it out there and see what happens. I mean, I'm not saying that this is bad. I mean, it's just, what else are you going to do? Like, you don't have time to build this sort of perfect thing. So, anyway, it's not like these issues are unique to Node. Like, this is a fundamental issue with horizontal scaling systems in general. Like, you start running processes on different computers that are all trying to do the same thing, and you add all these moving parts. Like, it doesn't matter what environment it's written in. I mean, it could be Python processes or whatever. Like, as soon as you start having components on all these different machines, like, it gets crazy. The thing that's, I think, uniquely Node about this is we have a few more moving parts because we can only ever use one processor. So it forces you to confront these issues when, like, maybe sooner than you would need to otherwise. I mean, at the end of the day, it's probably a good idea that we all confront them because, you know, we all want to grow big and have gigantic traffic loads. So, like, you just, because of that single CPU, like, you're going to have a lot of node instances. So this is going to come up. And so I don't want to give the idea that, like, I'm somehow like the world's expert on building like scalable backend systems. Like, there are people who have been doing this for a lot longer than I have, but I just happen to have fought a battle with this for the past couple of months. And so, you know, much like Xena the warrior princess, these ideas are forged in the heat of battle. So, I mean, like, I have some suggestions for, like, a couple of, like, basic things that you want to do. And you know, MDE talked about these a little bit. Like, you know, you want to get some good stats. You want to use that metrics thing. Like, totally do that. Log everything that you can afford to log. Aggregate your logs. Like, you're going to want to do all this stuff. But there's one aspect of you know, building a big cluster like this that I don't hear people talking about too much, and it's a pretty neat tool, and it's something that we get to do, I say, because we're doing this in JavaScript. We have a dynamic language that can be fed new code on the fly. So, like, a problem you have is you run into some situation. You're like, it seems to be weird. This weird thing happens. Like, I'm not exactly sure how to reproduce it, but let's put some logging around, like, you know, before it happens and after, and when it happens again, we'll look at the logs and we'll see if we can figure out, like, what might have caused that. Well, like, in order to do that, you have to push new code. Like, you have to add some new JavaScript, you know, restart your thing, and, you know, you'll hopefully have some clever way of doing it so your users don't even notice. But still, you have to, like, restart that process. And as soon as you restart the process, you initialize the state. And much of these bugs, in my experience, that are really hard to track down, are a problem of sort of accumulated state in this distributed environment that is really, like, if you knew how to reproduce it, like, you just do it on your laptop. But, like, there are problems because you don't know how to reproduce them. You don't even know what causes them, and you're trying to track them down. And so, like, restarting your process to add logging undoes the thing that caused it in the first place. So it kind of sucks to have to just add, you know, restart to add logging every time. So anyway, what you can do that's pretty interesting is you can just change your program. You can change your program on the fly as it's running without restarting it. So I know that that sounds crazy, and it is, but I mean, it's pretty cool. So what you can do is use this thing called the REPL, the read eval print loop. It's a way that you can run more JavaScript on the fly in your server. So I've got an example of a server that is modifiable, and let me just get that going here. Why is not that exiting? Come on, MacBook. There we go. Okay. Now I'm going to do an awkward maneuver here. Oh, jeez. Time to mirror. Arrangement, mirror. Okay, great. So let's just say you have a program. Wow, that's pretty big. I hope you can see that. So I wrote this little web server. It's this stupid, simple example, but it shows you how you can use a REPL to sort of turn on a feature in a server that is not on all the time, but is sort of sitting there waiting to be turned on, and then later you can turn it off. So an example of why you might want to do this is you might want to turn on, like, special tracing if something matches a filter, you know, like a regular expression of the user, you know, log all the things that this user does, or log all things from this IP address, or something like that. Just something that you want to do that you don't always want to do, but you don't know that you want to do it until it's too late and you would have to restart the process. So here's a really simple little web server, and I'm going to show you that in a second. But the kind of new to some people part is this REPL server. So this opens, listens on a Unix socket, which is, shows up as like a special file in your file system. You can connect into it. You can use a thing called SOCAT. You can make it listen on a network socket too if you want, but if you do it as a Unix socket, then you're sure that you can only get to it with access from the local file, from the local computer. So when you get this REPL started, you connect up to it. You can just run JavaScript commands. And the things that are in the scope of this REPL, you kind of have to initialize it with this context thing. So I make a little object, and you can just sort of hang stuff off it. And so we made this little MJR object, and we stick it in the context. And then from the REPL, you can see anything that's on this MJR object. So a little later, we have this counter, and then I've got a special handler here called onRec. And in the HTTP server, let's take a look at that. Every request that comes in, it checks to see if this onRec is set to a function. If it is, wrap it in a try-catch so you don't blow up your web server if that thing screws up, and run it with the request and the response object. I mean, just, super, super simple example. And so if we let's just go run that a second. Oh, and you probably can't see that, can you? That's too bad. How about this one? Okay. Oh, come on. Do I have to do this to get it to override the colors? Okay. So we've got our server here, and it's waiting for requests, and you can see we hit it like that. And we get this little JSON thing, and okay, great. Well, that's fine. It's been incrementing the counter every time we hit the request, so we can talk to this. There's this socket here and this little special file here, and you can talk to it with this thing called SOCAT. And so now we can dump that MJR object. We just type it in. The current value of that has these things on it. So you can run any JavaScript you like. If you haven't played with the REPL, you totally should. It's amazing. But so here we can actually change one of these node processes and make it do something else without taking it down. So we can set mjr.onRec equals mjr.logrec, and then we have to go curl that again. So server's still up. And I made it throw an exception just to show you that you needed. I forgot to put that back. Go back here. Where did I put that? Oh yeah, it's down here. Yeah, I wanted to make sure that if that thing threw, that it wouldn't take down the server or get screw it up in any way. So it does. Hooray! I guess I should have tested that. Anyway, now I am actually going to restart the server because it has to reread that value with no exception in it anymore. Anyway, so you get the idea. You can modify your running server. I mean, obviously you'd want to do this in a more sophisticated way, but this REPL tool is it's an essential way of tracking down these crazy things that have accumulated state. Because of course you can also just start poking around in objects. You just have to expose them to the REPL in advance. Make sure that you expose anything. Most of where your app stores things, all the state you're going to want to look at, make sure it's exposed to the REPL, because you never know what you're going to need later. And you can, when weird things are happening, you can bring it up and you can just poke around and just see what's going on in there. Anyway, that's all I have. Thanks. Any questions?
So you have a cluster of machines. You have 2 machines, and each of them have 4 node processes at once.
Sure.
And something bizarre is happening. How do you on some requests, how do you narrow it down to one process on one machine? Do you have any techniques for that?
Yeah, I mean, it sort of depends on how you found the problem to begin with. I mean, what we do is, we have the logs are aggregated and they're all kind of stamped with all that information. So the way in which you would notice that there was a problem was some line, some log line came through that's like, this is weird, and it has the ID of the node that generated that bad thing, and you can sort of. I think it's important, by the way, when you get your logs aggregated, that you can see a unified timeline. So you have 100 processes that are all kind of doing stuff. If they all can feed into at least a view, you can filter it down to a view where it's like node 1 did this, then node 2 did this, like that, because almost always there's some kind of weird interaction that the order is actually important. Like the timestamp and the node in order is pretty important. I mean, I don't know. Did that answer your question?
Over here on your right. So besides debugging a large cluster, can you comment a little bit about just performance stability and what it's like to operate a large node cluster?
I'm sorry, I can't really hear there's a really weird echo in here that's making it hard for me to hear you.
Can you comment a little bit about stability and what it's like to operate a large node cluster compared to other stacks?
Stability, like what aspect of stability?
Memory, do you find that node instances crash? Do you have to restart them periodically, that kind of thing?
Yeah, that's been somewhat of an exciting adventure. Node generally is really, really good, but it's very new, and sometimes you find rough edges. And there are things that don't show up under testing that only show up with real live production traffic that are weird. Yeah, but I mean, generally speaking, like I'm still very optimistic. I mean, Node is very, very fast, and the programming model, I think, is worth putting up with sort of these rough edges just to get all of that other awesome stuff. But I mean, generally speaking, like it's no more buggy than any other way you would write some server process. Like writing server processes is difficult stuff. You don't get to reload your, like a web page can leak some memory or whatever, but chances are you're going to leave that page anyway and it all gets cleaned up. But a server has to run for a long time, and so managing the resources in a long-running process, it's a challenge in any language. I mean, I think Node does a pretty good job. I think JavaScript is a pretty good choice. The garbage collection, say what you will about it, but it saves you from a lot of messes in a long-running process.
All right, so we've been using REPL to debug very complex node systems as well. And one of the very cool tricks that I found was that you can actually make a little bit of code that wraps a function and just passes it through. Because all the modules are global, you can very easily target a particular export of a module and wrap it in a sort of like event callback. So then you can hook runtime all these functions that you have in your node code.
Right.
Which is really cool for debugging, because then you don't have to be so much upfront with your assumptions about what you expose to the REPL, because the module space is global. You can inspect it.
Yeah. I mean, managing your access to the REPL scope is pretty crucial. Somehow you need to get everything in there that you're going to need, or that you think you might need later. Just simply exposing it in there is nearly no overhead. But if you don't have a handle to it, you will be sorry. And yeah, I mean, exposing the whole module scope, like, great. You get even access to even more stuff that way.
Matt, thank you very much.
You're welcome.